Okay, welcome back. This is part 2 of lesson 12.6, matrix equations. So now we want to create a matrix equation from systems of linear equations. So this is going to tie us back into our last unit, Unit 5, where we talked about solving for systems of linear equations. And this gives us another method for finding these different unknown quantities. So when we look at these, we look at these systems, we know these are linear equations. 3x plus y equals 2, 2x minus 3y equals 27. But we can use this information and set it up as if it were a matrix in order to find our unknown values. And the way we do that is we take the numbers that we do know, the numbers that are out in front of each of these numbers. So in front of this x, we've got a 3, a 1, and a 2, 2, a negative 3, and a 27. So we can use those to set up a couple of matrices. So we know that in this first line we have 3 and we have 1. And then down below in the next equation we have 2 and we have negative 3. And that's a matrix. And then if we were to multiply those by our variables, x and y, those would be another matrix, and those would equal 2 and 27. So, in other words, this 2 by 2 matrix multiplied by this unknown 2 by 1 matrix would equal this known 2 by 1 matrix. And so what we can do is we can find the inverse of this matrix up above. So we would input that into our matrix editor in our calculator. We would find the inverse, and the inverse happens to be 3/11, 1/11, 2/11, and negative 3/11. So that's our inverse of this one. And now we're going to multiply this inverse by this product from our original equation. So 2 times 27. Multiply these two matrices together, and we get 3 and negative 7. And so what that tells us is that 3 is what x equals, and negative 7 is what y equals. And if you want, you could see, how that would work in any one of these equations. For example, if I take 3 times 2, I'm going to get 6. And if I take negative 3 times negative 7, I'm going to get positive 21. Positive 21 and 6 equals 27. And so that works out. Okay, let's try another example. How this would work. All right, so again, we've got two linear equations, x plus 2y equals 2, negative x minus y equals 1. And we do have numbers here. We've got 1, 2, 2, negative 1, and 1. So we can set up a matrix. We know the first one's going to be 1, 2, negative 1, negative 1. So that's our 2 by 2 matrix. And that would be multiplied by the variables x and y, and that would equal 2 and 1. Fairly straightforward. And then I can find the inverse of this matrix. When I find its inverse, I'm going to have negative 1, negative 2, 1, 1. That's my inverse. And then I can multiply it by this matrix. Oops, sorry. 2, 1. Just ignore that number there. And that's going to equal negative 4 and 3. And again, we can double check that answer. Put it into either one of these equations. So for example, x is going to be negative 4 plus 2 times y, which would be 3. So we've got negative 4 for x. 3 times 2 is 6. 6 plus negative 4 gives us 2. So that one checks out. Okay. And you can, of course, also do these on a calculator. So we're going to do another one here. We've got 6x plus 7y equals, let me get this a little closer. There we go. 6x plus 7y equals 18. 2x minus 8y equals 42. So we can set up our matrix, which is going to be 6, 7, 2, negative 8. So that's our first matrix times the matrix xy. That's going to equal 18 and 42. Okay. And again, we can go through and solve this on a calculator. We can find the inverse of this and then multiply that inverse by this. And when we do that, what we'll find, this one doesn't turn out so pretty, is that x and y are going to equal the fractions 219 31st. That's what x will equal. And y is going to be negative 108 31st. And you could find that as well. And that's where the calculator becomes very, very useful, because these fractions and these numbers would be rather time consuming to do if you did all of this by hand. So I highly suggest getting very, very comfortable with being able to find the inverse and multiplying matrices on the calculator. Okay?